Moving on with the study of rational numbers, we have next our operations of addition and subtraction, which we would like to explore. Strangely, these operations turn out to be a little harder than multiplication for rational numbers, which is why I did multiplication first. I'm going to now turn to addition and subtraction, but we have to learn another technique before we can really do a good job with addition and subtraction. So let's take our two friends from last time, 2/3 and 1/4. I want to add these two fractions. Now I'm going to have some difficulty doing this. It's very similar to the difficulty you might have if you had this question: what if I want to add 2 feet plus 3 yards? The yard is itself 3 feet, so there's a relationship between feet and yards. Anyway, I want to add these two numbers. I can't just add 2 plus 3 to get 5 of something, because the units are different. So a yard is bigger than a foot, for sure. And so if I just add 2 plus 3 equals 5, that just doesn't give me a sensible answer. So it's the same thing when I add fractions. Here, the units are thirds. So I've got 2/3. And over here, the units are quarters or fourths. And they are different units, so I can't add feet and yards. I also can't add thirds and quarters. I can't add apples and oranges. So what I have to do is convert to the same unit. So if I'm going to add 2 feet and 3 yards, I'm going to go, let me see, let's convert feet plus yards. Yards is 3 feet, so this is 9 feet. So 3 yards is 9 feet. And this gives me an answer which is sensible and correct. 11 feet is my answer to this question here. So over here with the fractions, I have to convert them both to the same unit before I can add them. And here's one way. So 2/3 has all of these different representations, equivalent representations. This is kind of going backwards from our least terms calculation that we've been doing a couple times. Here we're going to go backwards, and I'm going to write down the whole series. So 2/3 is 4/6, is 6/9, is 8/12, is 10/15, is 12/18, and so on. And you see, it was actually easy for me to get this series of equivalent fractions, because I'm adding 2 each time. I've got an arithmetic sequence of numerators. I started with 2, and then I had 2, 2, 4, 6, 8, 10, 12. And the denominators, 3, 6, 9, 12, 15, 18. So these are all both arithmetic sequences, easy to get. Now, when I do quarters, I'm going to get similar. 2 8s, 3 12s, 4 16ths, 5 20ths, and so on. I have, again, arithmetic sequences, 1, 2, 3, 4, 5 in the numerators, and 4, 8, 12, 16, 20. I'm skip counting my 4 in the denominators. Okay, so those are my two series of equivalent fractions. And now I'm going to ask in which pair are the units the same? Well, there's no thirds in the bottom, there's no 6 in the bottom, there's no 9s in the bottom, but there is a 12s in the bottom series. So there's 8 twelfths and 3 twelfths. So I have equivalent fractions. Let's see what this does to my problem now. I know 2/3 plus 1/4 is equal to, I have 8 twelfths was a nice fraction that I found equivalent to 2/3, and I have 1/4 becomes 3 twelfths. Now the units are the same, so I can add them, and this becomes 11 twelfths. And then this is in these terms already, so we're not going to go any further with that. Okay. So we're done. We're done this addition problem. So that is a method for always finding the sum of two fractions. It always works, and it should make some sense to you. Now, let's try to speed this up, to accelerate this process, because we don't always want to write down the full list of equivalent fractions. So how can we do this? Well, let's turn back to our list here and take a look. Really what we're interested in here is the denominators. We want the denominators to be the same. And so we're only really concentrating on the arithmetic sequences of denominators. And so the denominators in the upper series here are multiples of 3, and down here they're multiples of 4. So what we want is a common multiple of 3 and 4. And in order to keep the numbers that we're working with here as small as possible, we want to find the least common multiple of 3 and 4. So this shows us that, once again, the material that we learned in the last section is going to be useful for us as we study fractions. So that's why I did the course in the order that I've done it, that I wanted to study the concepts of GCD and LCM before we got into fractions, so that I could employ those concepts in our fraction arithmetic. So let's do this problem once again using this least common multiple idea. So I'm going to take a look at the denominators of my two fractions, and I'm going to find the LCM of 3 and 4. And so we know various ways to find the LCM of 3 and 4, but so I'll just erase that. I'm going to use the Euclidean algorithm just because I'm on a roll with the Euclidean algorithm. So our Euclidean algorithm method for finding the LCM is to multiply the two numbers and then find their GCD. Down here, I'm going to do the GCD of 3 and 4. That's the GCD of 3 and 1, which is the GCD of 0 and 1 using division, and that is 1. So there is the number 12 is our GCD. So we know that both fractions are going to be 12ths, and now I have to figure out, let me see, 3 times 12, what did I do? I had to multiply it by 4 to turn 3 into 12. So I have to do the same thing to this guy here. I have to multiply by 4, and that's going to give me 8. What about this one? I had to multiply 4 by 3 to get 12. So over here, I'm going to multiply 1 times 3, 1 times 3, and I'm going to get 3. And then I'm going to do 8 plus 3 is 11 over 12. And then there may be another step at the end of this where we have to put something into least terms, but in some cases there's not, so we're just going to take the win here. We're done. We've again found the correct answer. So 11 over 12 is our correct answer. And so we did this without writing out the full sequence of equivalent fractions for 2/3, but we kind of did a little bit of a shortcut here. So the LCM is our shortcut for doing fraction addition. So let's take another example, slightly more interesting. So 5/6 plus 3/8. I want to add these two fractions. I'm going to do this by finding the LCM of 6 and 8, the LCM of the denominators. And that is 6 times 8 over the GCD of 6 and 8. Off to the side here, I'm going to have to figure out the GCD of 6 and 8. That is the GCD of 6 and 2. That is the GCD of 0 and 2 by division, and that is 2. So this is 6 times 8 over 2. That is 48 over 2. And that is 24 is the LCM. So the least common multiple is our common denominator. All right, so with the common denominator of 24, what did I have to do to 6 to turn it into 24? I had to multiply by 4. So I have to do the same thing to 5. Oops, that's a mistake. It's I have to multiply everything by 4. I multiplied the denominator by 4, so I have to multiply the numerator by 4, and I'm going to get 24ths. Here I have to multiply 8 times 3. So here I multiply again times 3. It's 3 times 3. That gives me 9. And so this final answer here is 29 over 24. All right, well, is that the final answer? Well, I need to find the GCD of 29 and 24. Now, that is the GCD of 5 and 24, which is the GCD of 5 and 4, and the GCD of 1 and 4, GCD of 1 and 0, which is 1. So that is in least terms. And most mathematicians would say at this point we're done, but there is one more step that we might want to go through. Sometimes we have a fraction like this, 29 over 24. It's called improper. Means the numerator is bigger than the denominator. And that is okay for mathematicians. Mathematicians think that this is actually fine and we should leave it alone. But some people don't like working with improper fractions. So what they do is actually do the division. 29 divided by 24. How many times does it go in? It goes in one time. The remainder of 5. And so they rewrite this as 1, which is this number here, and 5 24ths. That's this number, the remainder. So this is just ordinary division that we're familiar with. The integer part is the quotient. And the remainder is the fraction part. Okay, I don't like this. I'm not going to use it in this course. I'm just giving it to you here to show you how to do it if if somebody ever asks you about it. You may have to do this if you're a school teacher. You may have to teach this. This is called a mixed number. So you really have two choices for fractions that are bigger than 1. First choice is improper fraction. I prefer that. Mathematicians prefer that. The second choice is mixed number, and some people prefer that. Say it's used in construction trades, for example. It's very common to use mixed numbers. So it's good to know both of them. To go from an improper fraction to a mixed number, you use division. So we use division with remainder. And then to go from a mixed number to an improper fraction, this is the way I like to do it. So I'm going to take my friend here, 1 5/24. And in the context of a mixed number, this really means add. Usually when we juxtapose something, juxtaposition is when we just put two things side by side. So we have a 1 and a 5/24 side by side. Usually that means multiply, but in this context it means add. So that's why this is the addition of two things. Now, I know how to add two fractions. We just learned that, but how do I add an integer and a fraction? Well, I'm going to write my integer as a fraction over 1. Now it's a fraction, and I'm going to now find the common denominator. I'm not going to go through all the steps because I know what the answer is. And now I'm going to add the way we've learned. And we're done. So that's how we convert a mixed number to an improper fraction, just by adding fractions. Okay, so that is just a kind of an aside on mixed numbers. I don't use them very often. I think the textbook might use them occasionally, so it's something that we need to learn. And you also need to learn it if you're going to be a school teacher, a tradesperson. Sometimes cooking, for example, you use mixed numbers. So they are commonly used. All right, so that is it for addition of fractions. Now we're going to look at the subtraction of fractions. So here, let's take, I had an example here. We were working out 5/6 minus 3/8. So I'm going to take 5/6 and I'm going to subtract 3/8 from it. We do the same thing, the same basic operation here. We find the LCM of 6 and 8, and we know that that's 24 from our previous. So we write these both as fractions over 24. I multiply by 4. 6 times 4 gives 24, so 5 times 4 is 20. 8, I multiply by 3, so I have to do the same thing here. And I get 9. So I've got 20 24ths minus 9 24ths, and that is 11 24ths. I just subtract the numerators. I leave the denominator alone. That is how we subtract fractions. So it's pretty much analogous to the addition of fractions. Last step here, just to make sure, I need to put this into least terms, so 11 and 24. You do all the work yourself. The answer is 1, so I don't have to make any change to put the fraction in least terms. It's in least terms. And we're done. So that's all that there is to subtraction. It really just takes a minute to explain subtraction after we know how to do addition. So addition and subtraction both use the common denominator concept. We calculate a common denominator simply by using the least common multiple. Now, if there's, again, there's some difficulty teaching this to kids in grade school, and I think, again, it's because things are done out of order. If they knew the concept of LCM before they tried to teach fractions, then I think it would go much smoother. So you see, it just took us really a few minutes to learn how to do addition and subtraction of fractions. That's given the time that we've already spent on the LCM concept. It only takes a few extra minutes to teach how to add or subtract fractions. If we didn't have LCM, I think you could see how it could be a really complicated process to explain how to add or subtract fractions. All right, so that is it for addition and subtraction of fractions. I'm going to close this video and then we'll turn to division of fractions in a moment.